So yeah, as Robert said, I'm Rafael. I'm originally from Brazil, so if there's a weird accent, that's because of that. I do live in Wrocław, so I moved to Poland 8 years ago, almost 7 years ago actually. Next month will be 8 years. And yeah, I work with Go. I work in a company called Firm3. I've been doing Go since 2020. Well, actually, I started around 2017 in Go. Before that, I used to work with .NET. And yeah, so about this talk. I actually made this talk when this feature, synctest, was released as a preview in the Go 1.4. And it has changed a little bit now when they made the official release on the Go 25. I go through the change with you. Yeah. For this presentation, I didn't prepare like a slides or any deck. I decided to do it as a README because I think it's a little bit easier to go through the information that we have over there.
Is it better?
I can change to the light dim, so if it helps. So yeah. Let's get started. Cool. All right. So basically, in the Go 1.24 we had this new package called testing synctests, and basically what I want to do is actually walk you through the package, how to use it, some useful use cases, and yeah.
Can you please zoom in a little?
Yeah. Is it better?
Yeah.
See more.
Yeah, great.
Cool.
Thank you.
Yeah, it works. Maybe this one will be. Yeah. Let me do that in here as well, because I will forget. All right. So the first thing, if you're actually not running the Go 125 yet, you actually need to set the Go experiment flag to synctest in case you are running on the 124. But on the 125, you don't actually need that because the package made all the way through the experiment, and it's not an official support package. Another thing that is actually on the 125, on the 124, they used to run it with the synctest test. This is now, synctest run that you see here. This is not deprecated. They changed the function to synctest run, which is a little bit more expressive. And now it takes the T, and that's because that's why one of the reasons they changed the name from synctest test run to test to actually have another parameter which is the test. And that helps you in a few cases. I will tell you a little bit more. All right. So what is this? What is this synctest? So what is the problem they are trying to solve with this? So I already know that most of you work with Go on a daily basis, and I want to ask you, just raise your hands. Like, how many of you has written some sort of tests, automated tests, where you need to wait for something to happen on the background? And how many of you used solution, for example, like a time.sleep on this test because you don't control what's happening on the background and you need to assert after that happens? Okay. Or you use some blocking channel or Go routine to actually block the operation, and yeah, okay, cool. And how many of you figure out that in CI this test most often fails randomly? Cool, great. That's the problem we are trying to solve with the synctest package. Basically in Go, we had this, one of the biggest features of Go is actually allow you to write concurrent code easily with Go routines, as we know. But unfortunately, the testing package didn't give us enough tools to actually test this properly. And that's why we always come up with some with some time.sleep, with some blocking channel, with Go routines, and trying to synchronize the action that is executing in the background so we can make the assertions on the tests. And that's the problem they're trying to solve. So I'm going to show you just a quick example. So that's a test that's usually flaky by nature, right? So we have a Go routine in the background doing some fancy work.
Can you make it bigger?
Oh yeah, of course. Is it big enough? Yeah. Cool. So we have this fancy Go routine on the background, just adding a counter. And you have the test that verifies the count to see if it was incremented. The thing is, since this runs on the Go routine, if we don't sleep here, the counter will execute most likely before the routine is finished, and you're not gonna have the counter. So what we do, we put a thread time sleeping here. And if I run this test, just put over here. So if I run this test, most likely it will not fail. Yeah, because I have 10 microseconds. If I actually change this to 1 microsecond, for example, that may be too fast. Yeah, so it already fails. What is the solution? With synctests, we can now do a synctest.wait. So basically, you will do the go routine, you will do the same sleep, and I will get to that in a second. But then you have the synctest.wait that makes sure this go routine finishes execution before it proceeds. Alright? So I will just copy this guy and run it. So if I just go here and copy that whole thing, and I just noticed this terminal is not big enough. So yeah, and well, one thing that I wanna do the same microsecond here, to be honest. Yes, because this is your second. So if I just do here microsecond, yeah. Great, and I will run it again. And this test now is not flaky. So if I run this 100 times, it should pass 100 times. Now, another benefit of this package is that the time sleep here is not actually sleeping 1 microsecond. If I just change this to time dot minute, for example, and here as well, time dot minute, what's going to happen? You think PyTest is going to hang for 1 minute, and that's not what it does. I can even run it safely 100 times, and it just executes immediately. I mean, there's of course the compile time, and it takes 1 second, but it's not sleeping for 1 minute, as we see here. So what's going on here? Basically, we went through this, yeah. So basically the proposal they are making with these synctests is actually they are providing two things. When you call the synctest.test over there, synctest.test, when you do that call, it creates one thing that they call bubble. And what is this? This is a go routine bubble. Basically, the go routine that's executing your test, it creates an isolated test execution environment that they name it as a bubble, and it injects into this bubble a fake timer. So basically, what we're gonna see as a time operation inside of this test, it will be actually a virtual clock, and it will not count as a real clock. So if it spends 1 minute, it's not gonna spend 1 minute, it's gonna be just taking this clock and forwarding it to 1 minute later. If you say sleep for 1 hour, it will just pick the clock and forward it to 1 hour after. So basically, this is possible because of this go routine bubble. So they created this separated environment where the test execution and everything that's created inside that test is controlled within this environment, and they also control the clock. So that's how they are solving this problem. I tried to dig it a little bit deeper into the Go code and how they actually achieve that in the runtime, and it started to get too complex, so I dropped it, and I decided I'm not gonna go there. So what we need to know, it's a separated environment, it is a bubble, it's isolated, and it controls the clock. That's how they are solving this problem. One thing that I want to mention also is there was some critique on the proposal when they first raised, and they were mainly related to try to expand this package to do more things, and the proposal was actually very clear on what they are trying to achieve, because this topic can be huge, but they wanted to do it like step by step. So they started with an experimental proposal to see if it works, to see if it solves the problem, if it proves the value, and then there are mentions that they probably will expand this to add more capabilities, But right now they only did like the first initial step that allow you to test concurrent code in an efficient way. There were even asks like to make this production code, not only a test code, but I don't think they're gonna go there. So how that works? We have two functions basically. This new package has two public functions: the test and the wait. So the test, what it does, it creates this bubble that I mentioned to you, and it starts the virtual clock. Basically, it initializes the virtual clock into this date, 1st of January 2000 at the 0 hours. And this clock doesn't move, basically. This clock will stay into this date until you do something with it. And I think I have one example of that as well. Yes, so we have this test, and this test is not doing anything with time. So you have like a background processing. It just prints the time in the beginning. It ranges through it like 100 million times, I guess. Increments the count, prints the count, and prints the time. If we run this test over, the time should not move at all. So if we go back, I will just remove the count here. Yeah. So if we go back in here and run this test, you should see that, sorry, especially, yeah. So we have the Unix time when it started, Unix time when it ended, and it's the same, and just incremented the counter as we expected. So you can see the time doesn't move. It will only move if there is a need for it to move. So in this example here, we do the exactly same thing, but we add a sleep in here. And in this case, as I mentioned before, the sleep will force the clock to move, because that's yeah. So we can see the Unix timestamp here has changed. It has shifted. It has shifted. So why is that? Basically, the bubble controlled environment, what it does here, it ensures that if you have something blocked or waiting some time-related action to happen, in this case the sleep, it will forward the time to the point that unblocks the work that is blocked waiting for this condition to happen. So basically that's what it does. Cool. On the blocking, so that's what I was trying to explain. So basically, it only moves if the coroutines are blocked, basically waiting on the sleep. There are also some other situations where they are waiting for channel data to come, or some new taxes. And the official docs, this is a quote from them. So basically, the test will wait for all the coroutines inside this bubble to finish. If they are deadlocked, the test will fail, it panics. Tests should not be called within a bubble. What they mean by that, it means you have and this is very common in Go, right? So if you have like the synctest.test, if we do something like that, synctest.test, for whatever reason here, sorry. If we do something like this, and we copy this guy here, we paste it here. So if I just run this test, you'll see to complain because we are nesting two calls of synctest inside of test, and you should not do that. If I just save it and run the same test again, it should complain. Yeah, so synctest run called within a synctest bubble, so it doesn't really allow you to do that. And the reason for that is because you cannot create a bubble inside of a bubble, so it will start like almost like an inception, right? So, so they don't allow you to do that. The reason why they added this in the run, like the testing team, is to actually allow you to use some functions related to the testing, right? So you can have cleanup functions running there. You can have context. You can use the done channel in the context. So this is all like useful for your test scenarios. But on the other side, like I said, you cannot call another test run inside of it. You cannot do parallel. You cannot do deadline. So there is still some limitations. One thing though, Oh, I have some note on that. I'll go that later. So this test with moving we saw, and then there's the other function that I have over there, the wait. So with the wait, basically, the wait is a function to, because the main purpose here is ensure that the Go routines that you are waiting on, they have finished, they were scheduled, executed, and finished until you actually move on with your tests. And of course, you can sync them with the sleep, and usually that's how it works. So if you have a sleep, with this code is like a little bit of a nonsense because they are all examples, right? But if you have a sleep in here, you should match the sleep in here. And basically this is just to kind of synchronize the clocks in a way. But you also have the wait in this test. And what this wait is doing, even though there is the sleep, you have no guarantee that this Go routine was actually executed on time. It was scheduled and executed by the Go runtime until this function, when the next step of the test, the assertion happens. And that's the purpose of the wait. So wait will make sure that whatever is there to be executed will be executed, so the next step runs. Yeah, the wait can only be called in the bubble, right? So you can only call synctest.wait inside of a synctest function. So if you try to call it in a different type of test, it will not work. And yeah, so basically this bubble that they create will control all the Go routines and will manage the lifetime of them. Like I mentioned, it will panic if they are in a state that they call durably blocked and cannot be unblocked by moving the time. I already mentioned it's responsible for managing the clock, so moving the clock forward. And there are two types of blockage, right? So you have durably blocked and externally blocked. And we only control with these tests what is called durably blocked. And the definition for that is basically just a few situations, right? What they consider durably blocked is actually sending or receiving on a new channel, sending or receiving on a blocked channel, and this channel was created within that same bubble, and that's a little bit interesting, and there are some implications. So the reason for the way this works, like the test, the sync test of test that you call over there, like the run, it has to have the control over the code that it is executing. So imagine you have, for example, this is not really meant to use, at least I cannot see a way of using this with test main, for example. So if you have some sort of end-to-end tests that initialize an external dependencies, create a test main, and then you have like your sync test.run, trying to reuse those, like let's say for a component test where you depend on a database or something like that. That's not really the case, because this Go routine bubble, it needs to control all the actions that you have, right? All the Go routines that you're creating, all the channels that you're creating needs to be like within the scope of this bubble. Another thing they consider, like the select statement, where every case is like a durable block. Time sleep, conditional wait, and the wait group. And everything else is what they consider externally blocked. And a few examples is basically syscalls, network calls, reading from a socket, for example, channel operations where the channel was created outside. So let's say, like I said, you have a test main and you create a channel outside of the test, so this will not work. And mutexes. And mutex may sound strange, and there was even a couple of questions regarding that on the proposal. And the reason why they didn't include mutexes is because they are way too short-lived, and this would be a little bit complex for them to manage. And the counter-argument of the guys implementing this was like, okay, when you create a mutex, you just basically, you lock something, you do whatever you do, and then you unlock it. And this is usually quite short. So they considered for this first iteration, let's leave mutex out of the equation, and that shouldn't be too much of a problem. I think I have another example. Yes, the wait. So this is a classical wait test from the examples. So basically here we have an after func that will be called once the context is cancelled. And I wanted to assert on the function if the function was called, right? So again, how would you do that before this? Either you would put some channel and you would wait until this channel is closed and then you would check, or you would put some sleep and you know already. So with this synctest wait, you can just do like this. And there is an interesting catch here that I don't know if you may see. But just give me a second, let's just prove it that it works. Yeah, it does. Cool. Does anybody see a problem with this test? Just forget about all about you know about sync tests, right? If you were running this test without the way it is, would that be a problem, Go? Yes?
I think there's a race condition on the call.
Yes, that's exactly it. There is a race condition in the code. And do you know why there is no race condition in the code?
Because there's algorithms.
Yeah. The thing is, the sync test wait also solves this problem.
Yeah.
And that's a simplification basically, right? So the race condition that Robert is talking about, you have the variable called, which is just a simple Boolean variable here. It's flipping the status inside of this function that's called over a routine, and you are asserting this in here, outside. So if we do this test, if I just duplicate it and do it without sync tests, so it would be something like that. I believe, wait, true. Yeah. So if I would do something like that, and instead of waiting, I would do, because I cannot wait here anymore, I would just do the simple time.sleep here for the laziness of 1 second. Time.second, yes. So if I run this test with race conditioning on, it should alert that there is a race condition. Yeah, it does. The race condition was detected. So basically, when you are using the sync test, the wait, it makes sure that this line will be only executed after this go routine is scheduled and executed. So that eliminates the race condition, which is quite interesting because, I mean, you can write way simpler test code. Now you don't need to care. I mean, of course, if there's a race condition in your code, you need to care about it. But if you're just like syncing up states for the test, the sync test wait is quite handy. It eliminates the possibility of a race condition. So that's quite interesting. Cool. What else do I have? There are some limitations.
Can I ask a question?
Ah.
Doesn't it mean that because of this you can accidentally not find race conditions in production code? Because it can also synchronize the conditions that are actually in the production code?
That's a good question. I don't think I know the answer. That's a good question. Yeah, I think I don't think so. But yeah, I don't think so because in theory, yeah, maybe. I don't know. I don't know for sure. I would like to test that. That's a good call. But yeah, probably it might though, because if we think about it, it will. If you have a code that creates 2 go routines and they are writing and reading to a Boolean without synchronizing themselves, yeah, that's a good test. If we have the time, I can try to do it and we'll show you on the after. But yeah, maybe it happens. Cool. So there were some limitations. If you are running on the 124 and you do something like these ones, they would just stuck in loop forever. Basically because like here you have just a ticker and here you have like an infinite loop with sleep. Now they don't, so it's fixed. It will just say that it's deadlocked, it's not doing anything. Actually, sorry, if I do that now, it should just it should just finish actually. So if I just replace this, just do this, and run it again, I think it will just finish. Yeah, it just finishes, exactly. Also, if for some reason you are using older versions of Go, it will not work. For example, if you have like in your Go mod something set to 123, actually prior to 123, it will say that the synctest does not support with the async timer chain. And the reason for that is on the Go 123 they changed the way the timer channels are implemented, and the synctests only work with the newer implementation. It doesn't work with the older one. That's the same thing if you actually flip the Go debug flag to use the older implementation. It will not work, so it's a limitation. It doesn't really work with benchmarks, and the reason for that, they say that if you're running a benchmark, you probably want to run it as close as possible to the real environment, and the bubble and simulated clock is not the best way to do this. So they decided not to support benchmarks. It was actually even supported, not supported, but like on the experimental package, it wouldn't complain if you try to do a benchmark test. It would just fail badly. But now they actually have a specific error saying that you cannot run it. On the other hand, you can use with test fuzzing if that's one thing that, with fuzzing tests, if that's one thing that you are fancying to. I didn't play much with fuzz, so it's I can't tell you much, but yeah. And there was an issue also on the proposal where the 124 version, like it didn't print like useful stack traces. So if there was a deadlock, it would say everything is blocked, but it wouldn't tell you what's blocked and where. This is now fixed, so it's way better. But yeah, there was a workaround that you could print the debug stack or use bprof to just take a look into that. But yeah, I actually had a couple of tests on the limitations here as well. Yeah, but yeah, we already saw this. And there's one more example I wanna show you. And I tried to come up with something for kind of what would be maybe a production code, but it's really hard to just like come up with a meaningful example and make it small enough so people can understand. This is actually on the first version of this talk that I presented in Wrocław. It was way bigger, and I had like an events processor that was actually publishing messages, and the messages were picked up by a worker, and this worker was calling an HTTP server, and it was actually verifying that everything was called. But in the end, the example was like so big and people were getting lost. I was like, okay, let me reduce this a little bit and see if it makes more sense. So let's see. So this is an events processor, and think about it as you put a message in the pipe, it picks up the message, processes it, and marks them as processed, and that's all. So we have the struct, usual, where we initialize this events processor. This is the new function that returns the instance of this guy. It just initializes our buffer, that's just a channel, buffered channel, and a process, which is basically a map of a string bool just to see what events were processed. It's very simple. The events processor has a run, which is basically a fire and forget. So it calls a routine that will start looping through the event, through the buffer, and will call a new routine to process each event. The process is pretty simple. It basically just locks a new text on this processed map, grabs the name that we put on the event, and flip it to true. We have a helper method here just to copy whatever was processed to an out variable, so we can assert it on the test. We have a shift down that just closes the channel in a way that it will unblock this go routine here and it will finish. And we have the send, that should be our the consumer code would call to actually send message to the event to process. and I have two tests. One that is how this would be processed before sync tests, and one with the sync tests. So I try to make it, again, as simple as possible. So we just initialize the processor. We defer the shutdown. We have a name. We send the name. We sleep for a second, and we verify if the name was processed. If it was not processed, we error out. This test is fine-ish. The problem here is the sleep second, as you already know, because this test will sleep for 1 second, and it may 1 second may not be enough in the CI. I actually already run the other one as well. Cool. The improved version of the test. It is this one. Basically, we wrap it up with the synctest test, and here there is no sleep. Basically, what we do, we leverage the wait. So yeah, it's exactly the same test. We call run with the first shutdown. We send John Doe to the pipe. We wait for the pipe to be executed, and then we check for the process. And yeah, as I mentioned, as you can see here, like, it works. If I flip the count here for, like, let's say maybe 10, maybe the 1 second will fail, but with 1 second it might be hard to fail. It's too big. Too big and too powerful skill. Let me just bump this down to maybe microsecond, for example. Yeah. Maybe that would, yeah, then it fails. Yeah. Eventually it fails. That's the that's the next part about it. Cool. Yeah, I think that was basically all I wanted to show. The main takeaways, in my opinion, with this package is it is useful, especially if you are doing some sort of code where you need to synchronize time and go routines in the background. It's not really useful if you are trying to do some end-to-end tests or tests that relies on other components. For example, I mentioned that I made this more complex example where it was actually calling an HTTP server, and so if you have, for example, an HTTP call inside of that events processor, there are limitations. You cannot really put an HTTP server on this because it would be an external I/O. But if you take the proper interfaces in, you could actually simulate this with the net pipe that simulates you can kind of fake an HTTP server with the net pipe and have all in-memory communication. So there is a way to do that, but it won't really work with like more robust end-to-end tests. And for me, this is like I would say the biggest downside of what we have right now. Especially, I don't know about your use cases, but on my use case, on the use case I have at my company, we ended up with a majority of our tests, they are end-to-end style tests, and they rely on real components that are spinning up, like Docker Compose or Tilt or something like that. And yeah, in this case, this is not very helpful. Cool, let me see. Yeah, there are some references here. If you want, these are all public. You can find it's probably too small to read. I'll put it in a terminal. Yeah, you can find it out there if you want to. And yeah, do you have any questions?